Okay, so we're going to go through parameterizing a torus. This problem's hard. There's no shame in being hung up on this one. I did ask you to think about this for a little bit, and I absolutely want you to think about this for a bit before you dive into watching the video. I'm going to give a couple pausing points here for various levels of hints, but first things first, I'd really love it if you thought about this problem for at least 10 or 15 minutes before you watch this video. So if you haven't thought about this for a while yet, please stop, go ahead and think about it for a bit, come back. Okay, now that you've thought about it for a bit and you're kind of stuck, I'm going to give you a first level hint. So our first level hint is we're looking at these two circles, right? So there's a dashed circle that goes around the z-axis, right? So that's this circle here, which I'm outlining in red. And then there's another circle, which I'm going to outline in pink. And that's this circle here, which is the one that's getting spun around, right? So here's a kind of copy of the pink circle over here. And here's another one. But there's really only the one red one, right? So that red one's going to go all the way around the back and then pass back through here. I hope the two circles are making sense. Are you on board with those? Okay. I'm going to this first level hint, I'm going to add that there's also a triangle, and this triangle's in the XY plane, right? That red triangle is flat in the XY plane. And I'm going to add drawing a pink triangle in here. And the pink triangle is sticking straight up out of the YZ plane. So I'm going to draw those two triangles here. So one of them is my pink one. That looks like this. It's got a right angle in the corner. This far side of that is sticking straight up out of XY, which makes it Z. The bottom, I don't really know. The angle I know is alpha in this picture. So they told me that angle was alpha there. And I'm going to leave figuring out what the radius is to you. The red triangle, let me go like this, right? So I'm drawing this one bigger because it's a bit bigger. It also has a funny little bit to it. So if I draw that hypotenuse on that, oops, that didn't work. If I draw the hypotenuse on that red triangle, it doesn't actually go to underneath the black point. I need that little extra bit of pink there. So I'm going to add that little extra bit of pink here, and then I'm going to scoot my drawing down so you can actually see the silly thing. Okay, so I'm hoping these two triangles make some sense. The red one then has an angle in it that's theta. That's a right angle. I want to label these sides X and Y, but they're not quite X and Y. So there's a little bit extra here, right? So kind of added to the red triangle, there's actually a slightly bigger triangle here. I'm labeling black, right? That triangle also has an angle of theta, right? Similar triangle. And the sides of the black triangle are X and Y. So this one here is the X side. This one here is the Y side. This is my kind of first level hint. So take these triangles, think about this for a few minutes, maybe 20, 30 minutes. You guys should be able to get some of the way through these triangles. Pause the video here, come back, please. Okay, so now that you've thought about it for a little bit, I'm going to kind of push on our hint. So the push I'm going to give you is I'm going to think about what are the radii here. So the radius for the pink triangle, they tell me that I'm finding a parametric rotation for a torus obtained by rotating about the z-axis, the circle in the xy plane with the center b, 0, 0. That means that initially the X value here out to the center of my circle, that's B, which means the radius of the kind of, now, the radius of the, I guess the red triangle is B. You guys see that? So I want to put a B here. The B is red. It's not the radius, like it's not the proper radius X. It's just the radius in the XY plane of the center of that circle. You guys see that? So the thing I'm actually after is this black X value, but I've got a B that's this red hypotenuse value. Okay, fine, whatever. Like we're going to get there. For the pink, the radius, it says the radius of the circle that I'm rotating is A. So that's the radius of the kind of pink triangle, right? So that's the hypotenuse of the pink triangle is A. And then I hope you can remember some like basic trig here. So if you remember some basic trig here and you feel like this is a little bit of a hint, pause here. See if you can get a little further with this. I think you can. So that's my second level hint. Pause here, spend another couple of minutes. Okay, I'm assuming that you paused and you got stuck, and so you're back. So here's my hint for you're coming back. I'm going to take this Z, and I'm going to say, okay, Z is actually equal to, well, it's kind of opposite of alpha, right? So Z over A would be sine of alpha. And the radius is A, right? So I could think polar at it. I could be like, oh, it's R's sine angle. Great. Or I could think to myself, let's see, Z over A is the sine of alpha. So then I'd multiply both sides by A and I'd get Z equals A sine alpha. What else? I don't care how you approach that. You're going to get something like this. That's just straight up the Z value. So ultimately, my quest here is to find torus as a function of, say, theta and alpha. Put a vector hat on this thing. And I'm going to say that's going to have three components. I know now the last one is going to be A sine alpha. Check, done, awesome. That one's sorted. Now for the other two, I've got a little work to do. So the little bit of work I've got to do is I need to think about X and Y here with my slightly bigger triangle. And in order to think about my slightly bigger triangle, I need to know how much bigger it is. So my hope is that you could think about this side here and realize that that side there is going to be A cosine alpha. And that bit is actually also this little bit up here. So I get an A cosine alpha up here. And that means that not for the red triangle, but the slightly bigger black one, right? The hypotenuse here is B plus A cosine alpha. And then I'm hoping that you can do a similar trick to figure out X and Y. So please, I think you can do this. Pause here, figure out what X and Y are, come back in a second and double check. Okay, I'm assuming you came back. Now you're double checking. If you haven't and you're cheating, please pause the video and actually go back and figure it out. All right, so I'm going to use my radius, and I'm going to say that X value here is going to be B plus A cosine alpha, all of that, which is playing the role of my radius, times a cosine theta. Now I need a little more space to type, so I'm just going to take this guy, scoot it over. And then in here, we're going to do a B plus A cosine alpha. Again, that's playing the role of my radius, so it's still a cosine, even though what I'm going to apply here is the sine of theta. And then our next step ought to be to graph this using Desmos or something and check that it worked. Okay, so far all I did was just type in what we got into Desmos. I called alpha U and theta V, just because. I guess those are backwards from what I wrote down. So maybe let me change them. So that'll be a V, that'll be a V, that'll be a V. These will be a U and a U. Okay. So far, I've set A and B both to 1. I seem to remember from the problem that B was supposed to be bigger than A, so I'm going to move it out a little bit. I'm noticing that that doesn't look like a torus. What do you think the problem is? I think the problem's that my U and V are going from 0 to 1. I'm going to first send this all the way around. So I'm going to go from 0 to 2 pi in the U direction. So that's the theta direction, right? So that's rotating all the way around the Z axis. And now here I've only got, my guess is maybe we go to pi or something. Oh, whoops. That's only the top half. So I probably need a 2 pi there. Okay, cool. And then I can make the thing, I don't know, wider, I guess, right? And then I can make the, what do you call that? So I'm going to call that the diameter of the ring is something like B, and then the thickness of the ring is something like A, right? So I can make a kind of a tastier donut by increasing A, and I can make a weirder donut by increasing B. There's some weirdness here that you get when you pinch your donut down too much. See this guy? It's a little bit hard to see what's going on in there. Oops, not what I wanted. Where's transparent figures in here? So there's some weirdness going on inside there because we're rotating the circle around and it's kind of intersecting with itself. So let's keep our B bigger than A like the problem suggested, and then we can look at a torus. Cool. Hope it was helpful. I hope you guys learned something from this. If you're not totally sure what happened here and you've seen like you should have seen enough here to get through this, right? So I'm hoping that you kind of understand what's going on. If you're not totally sure where I'm coming from here, maybe back this up, go back to the spots where I asked you to pause and try to produce the next step and see if you can understand why. If you have any problems, let me know. Hit me up in the Discord. We'll chat about it some. You guys got this. Oops. Oh well.